The topic of this problem is operational amplifier circuits. And the problem is to determine I out in the circuit shown below. It's a circuit that has two sources in it. It has an independent current source and an independent voltage source along with two resistors, a 10 kilo ohm feedback resistor and a 20 kilo ohm load resistance. I out is measured as the current through the 20 kilo ohm resistor. So to solve this problem, we start with the properties of an ideal op-amp. So we'll draw the symbol for an ideal op-amp first. It has two inputs, it has an output, it has a ground, internal ground, and each one of these inputs has a current associated with it, and each one of these inputs has a voltage associated with it, an inverting and non-inverting input. The properties of an ideal op-amp tell us that the current in both of these inputs are equal, and in fact are equal to 0. So I minus is equal to I plus, and it's equal to 0. Also, the ideal properties of op-amp tell us that the voltage at the inverting and non-inverting inputs are equal to the same value. V minus is equal to V plus. So we're going to use these two properties of an ideal op-amp in order to solve our original circuit. So let's go and back to the original circuit and solve it. So we know the voltage at this point because it's ground at the bottom of the circuit and we go through a 5-volt source, so we're at 5 volts at the non-inverting input. We know through our properties of the ideal op-amp that the same voltage is at the non-inverting input as the inverting input. So that tells us that this node is also at 5 volts. So if we know that, then we can sum currents into this node, or perhaps we call this node 1, and we'll sum currents into that node in order to find the value for this nodal voltage, so ultimately we can find the current in the circuit. So let's do that. Let's sum the currents into node 1. So we're going to do Kirchhoff's current law at node 1, and we're summing the currents into node 1. First of all, we have 0.1 milliamps flowing into node 1 from our current source. We also have current flowing through the 10 kilo ohm resistor into node 1. It's going to be the current at this point, let's call it V out, minus the voltage at this point, which is 5 volts, divided by 10K. So it's V out minus 5 volts divided by 10 kilo ohms. And we also have the current flowing out of the inverting op-amp, or inverting input of the op-amp, and we know that that current is equal to 0. So we're going to add that in for completeness, and the sum of those currents using Kirchhoff's current law are equal to 0. So it's an equation that only has one unknown, and that's this V sub 0 term. So if we solve for V sub 0, we end up with a V sub 0 that's equal to 4 volts. Now that we have that value, it's easy for us to find the value for the output current through the 20 kilo ohm resistor. Because we know that current, I out, is equal to V out, voltage at this node, minus the voltage at the bottom node, which is 0 volts, divided by 20 kilo ohms. And V out is 4 volts, and 20 kilo ohms gives us 1/5 milliamps for I out.